the just click on the Fluent similar method and import the geometry from your desktop or in your folder turbo generator and edit on design modeler. Okay, design modeler window will open after the design modeler window open. You just click generate option for import one geometry. Then only we can see the our geometry on the graphics window. So after the opening of design modeler, just click on the import one and right click. You can see three options. In the three options we can see that one generator option is there. Just click on the generate option. Here it will take some time because I have more than 20 bodies. I think 23 bodies there. Yeah, 23 bodies is there. Each body, yeah, this one lot of bodies is there. Okay, so these bodies contribute the faces, that is a cap, like what is that, it act as a outline of the turbo generator fluid. That is a turbo generator outline box. So we need to fill this hollow body portion. This is hollow. And in the previous cases we creating the fluid region directly, but here the given geometry is the hollow body. We need to fill this turbo generator using one tool known as fill. So I will show you how to fill this geometry with the fluid. So you can go to tool option. There is one option is there, fill. In that we can see then there is expression type by cavity. This is by cavity means we can using this option by selecting a body, a fluid body or some filter body. It will become cavity. Here we need to cap the body, so we using by cap option. Just click on by cap. So initially we can get a fill like this by cavity. Just click on there. There is an option called by caps. Here by caps option we using for filling the outline box, so we need to select all the body. Here already inbuilt defaultly we can see all body is selected as target body. So this all body, like this all bodies act as a target body. It is using for filling this inlet portion, at this inlet portion. Okay, then we not preserve the capping bodies. We not need to preserve the outline box. We need only the fluid region. So we can go for generate option. There is a cap surface inside. Cap surface is filling this. We can see that inside. Okay, you can see the fluid inside cap surface. Inside cap surface is fluid, but this bodies is not these bodies is not needed for analysis. So we need only this fluid region. We can name this region as fluid. So no problem, we can change the name also to become the fluid. All other regions, these solid regions we need to, these are solid regions. We cannot need for analysis of fluid. So we need only fluid region inside this turbo generator. So we can suppress these bodies. So click on the turbo generator first one and click shift button, and we can click the last turbo generator. Then we can select all the bodies except this fluid region. Then we can suppress these solid bodies, and we can see only the fluid region. Okay, after rotating this, we can first we need to after that we need to create the inlet surface. So from the toolbar we need to first you select the face selection pointer. Just select the face selection pointer and click on the inlet face and right click. We can see the name selection and change the name to inlet. Okay, after that generate the inlet button. Then we need to, after that we need to create the outlet surface. So this is one outlet. Click on shift, select next one. Not select first select one inlet, after one outlet, and then click on control button in the keyboard. Then click second outlet, third outlet, fourth outlet, fifth and sixth. These three six one together we can consider as one single outlet. So I create outlet by using name selection outlet. So if we if we select, if we click on outlet, we can see six outlet faces is showing on the graphics window. Okay, therefore there is one inlet and another one outlet, but that outlet contains six faces. So this is the procedure we need to complete in the design module. After that, after the section, we can go to mesh. We already discussing this portion, so I directly go to automatic meshing, so I can update directly here. You can go, but you just practice that meshing methods for this also. In the initial case, sometime it is not we get the good quality, so you need to change the method. If we change the first method, we studied different type of method for meshing: automatic method, tetrahedron method, hexadominant method, and after that multi-zone method, sweep method. We can use different type of methods, and you can compare the quality of the mesh. After that, you just fix on any one of the method. After that, you can change the sizing of the elemental portion of mesh by using sizing option, body sizing option. Okay, after the meshing, you just go to, after meshing, we similar method, we go to the setup option. Just wait for, okay, meshing is completed, we can start setup. Just double click on the setup option. This station we have using only one, because in this core one have only license, so we selecting only one process system. Just click on the start option. So here the problem is, this is the student license, can go more than 5 lakhs. I think 5 lakhs is else is there, we more than 5 lakhs else is in our um, case. So we need to reduce the mesh numbers. Yeah, we need to reduce the mesh elements, otherwise we need to increase the size of each mesh. Click on mesh, can check how many numbers of, okay, 6 lakhs 8,000. We need to reduce below 5 lakhs. So then we can change the body sizing option. So you select sizing, select the geometry here, apply, and after that we need to change the elemental size. It is 3 into 10 raised to minus 2, that is 0.003. We can change to 0.00329. Now it is 81,000 only. So I think the quality will be reduced, but in this case we can't go for better quality. I think so, because we need to reduce number of cells. Yeah, this quality is not good, but we need to accept this quality for here, because we can't go with the good quality in this range of elements. If, because if we go to more than, if we need a good quality, we need to improve number of elements also. That's not possible here, so we in this case we not taking the quality matter, we focus on this number of elements because we need to reduce the number of elements below 5. First we can check this number to 5.005. Okay, click on update. We can check the number of elements under quality also. I think the quality is not good because we reducing not the elemental size, not reducing elemental size, reducing the elemental numbers because of this restriction. The scanner is 0.99. Okay, this okay, 4 lakhs. We already come in, we already opened the setup and started with the early mesh, so there is some uh, data is there. So first we need to clear that data by clear generate data. So in this case the data will be clear, and after that we need to reset option. Now the details and all the data are saved in this case is now already deleted or clear. So after that refresh, so it is again come to the initial point. So we need to double click on setup. Again they are asked the double precision start. I think this case machine problem is not happen, but quality will affect the solution, that is a problem. But we have no other option because this is a student version. So if we go to improve the quality, it will increase the number of cells. So beyond the 5 lakhs it is notable in student version. So there is a general option is there. We using pressure base and steady condition. Click on gravity. Again we click gravity and put the value of center of acceleration due to gravity negative 9.81 because happening in the y direction but in the negative y direction. Then we go to model. There is one energy option is there, but here we didn't uh, focusing on energy. We here there is no temperature, anything is there. We focus on viscous, so double click on the viscous model, and we using k epsilon model with the releasable k epsilon. You can use standard. I am here using realizable method. It is more good for air condition, air as full fluid. Here we using air as fluid for, so that I am using realizable method. We can click on OK button. After that we don't need to change the material because it is already air is there, inbuilt aluminum is there. We will not need aluminum, but we need air. We didn't change the fluid region, and cell sound condition is same, no need to change, it's already fluid. Click on fluid, we can see air as fluid because only one fluid is there. So if we have another one fluid, water or any other um, oil, something like that, we need to change the cell sound condition. But inbuilt here air will be differently come in the fluid region, so we not need to change anything. Here we can close. You can directly go to the boundary condition. Here two boundary conditions is there, one inlet and outlet. Here one change in the inlet because it's defaultly it will come as velocity. We need to change this matrix to mass flow rate. So just close this, and edit option is there. Just otherwise you click on boundary. Here you can see boundary condition in this task page. Otherwise you can directly edit here. One option is just click on inlet. Then there is one plus option is just click on there. We can see inlet velocity. We change this and right click on the inlet. You can see edit option. Just click on edit. We can do edit the geometry, anything there. uh, but but the problem is again come inlet as velocity. So we need to change this velocity type to mass flow rate. So double click on boundary condition. There the task page we can see boundary conditions. Click on inlet. We can see type as velocity inlet, we can change this velocity inlet to wall, symmetry, pressure outlet, anything. We need to this as mass flow inlet. So I click on mass flow inlet. Now the inlet become mass flow. Now the inlet become change from velocity to mass flow. We can see the figure momentum reference frame is absolute, and we are using the specification method as mass flow rate. You can change this mass flow rate here 0.15 kg per second. So there is a gauge pressure is 0, atmospheric condition is we using. Just apply, and after that apply, we close this window, and we need to change the outlet. But here the type is already pressure outlet, we don't need to change this to any one of these. So we can go with the pressure outlet. We need to change the pressure outlet to atmospheric, but in the case this is already in the gauge pressure 0, that is atmospheric condition, we don't need to change anything here. Just apply and close button, click on the close button, and after that we can go to initialization. There is that initialization, yeah, there. Just click on this initialization. There is one option, hybrid option is there, another one option is standard initialization. Hybrid initialization is we can go for with the hybrid initialization, that is not a matter, it will take some time. And standard initialization, we can give the instruction which from which where we need to commute, is a commutation we need to start, or initialization from is starting region we can select. So we can select here initialization from inlet, and we can change the pressure, anything, any values here also. Okay, I'm changing the commutation from inlet. You can also go for also on condition, that is not a problem. And started with inlet option. Okay, then click on initialize. Just wait for initialization. Okay, initialization is completed. I think uncompleted. Then we can go for the iterations. We can go to iteration. You can go for 1000 iterations, no problem. Now I am going to 500 only. You can change to 500 or 600, that is not a matter. Okay, after completing the calculation, just click OK, and here change the number of iterations to 50. You can go to 100, it's not a problem. After completing number of iterations, I can go to result. Similar method, we first create the plane here. Just click on plane. Okay, then plane, you can plane. Okay, then you can select XZ plane. XZ plane, there is XZ plane. Okay, but here this geometry is not in the origin. You can check here scale, this is not in between the center point, so not 0 is not as origin. So we need to find which point we can take as the mid of y. We can see it is changing from 0 to 1.14, like that. We can take 0.1, 0.14. Okay, point here it is 0, it is 0.7, something like that. You can take 0.7 or 0.8 or 0.9, anything. So I am taking 0.75, or you can take any value, that's not a problem. You can take in between these mid values. I think this is point 0.08, sorry, 0.08. Okay, or you can take on as zero point 0.1. That is correct. 0.1 is correct. You can get some more correct. Okay, 0.1 is the correct one. 0.1 is the correct one. You can change this contour to another one, or you can create another contour for velocity also. You can get the velocity contour. You just of this and use the plane one as the location, then we get velocity. Okay, this is the velocity. So first create the contour, first create the plane with the y as zero point 0.1 and apply. Then you go to contour 1. Here you need to change the location as plane 1 and apply. Here the variable is pressure. In the second case, you create the contour from here. We can change the we must change the location to plane 1 and change the variable to velocity. Okay, this is for contour 1. I will take this is for contour 2. Here the variable is velocity, then apply. This is the method. Then we can go with another one option is there. ISO surface one option is there, so we can create ISO surface. It will helpful for what is what are the lines with the streamlines with the same velocity, or this limit of velocity, which region have this limit of velocity, like we can create. So first we need to uh, find a or we need to study the what is streamline. We can select a streamline. You already studied the streamlines. So here we using this 3D streamline, we can get all the portion. We can go for surface streamline. Here we can select a surface where the line with the velocities as variables. Here variable we can select variable velocity. Then we can just click on there. We can get the streamlines, but we can change the number of points to 100 anything. We will get more number of lines here. So I change these points to 100 from 25. Yeah, we get a lot of points. You can also change some more points here. We can get a crowded one. Yeah, it will be okay. There is we get a streamline with a lot of points. So we using some surface streamline for planar section. If we go for 3D streamline, it will show for all the domains. Can go for 100 play. It will be a 3D view. Okay, this is a 3D view. Here I am only taking 100. You can take more than 100. It will be get a good result. Okay, I am, but in this case I am needed only surface streamline. I am go with the surface streamline with the 200 points. Okay. Okay, if we need ISO clips, like I will explain. You need a plane with some range of velocity or some range of pressures. You just click on ISO clip, then click OK button. You can see here one option is there. Inlet option is there. You can change to plane 1. After that, there is one. You can add a new visibility. Here here it is pressure. I can change this to any other variables also. I can change to velocity. That is a problem, not a problem. visibility parameter you can change. Here I am changing this to, you can go for with some value, for example, okay, this is the velocity contour. Here, so I am go with velocity with the range of 100 or 150 meter per second. Can check what happened. Okay, this is happening, this is out of range because 0.15 145 anything, that's not a problem. Yeah, off, and we can click. We selecting plane 1, play. We'll check once more this. The maximum range is 43.448. Okay, we change the value to change the value 40. Okay, similar method we can create the plane with some ranges of so that is greater than some range of velocity, some range of pressure. For example, in the contour, this contour 1 and contour 2. This contour 2 is showing the velocity, and the range is in between 0 and maximum 43.449. So we need to see this 43.448 or 30 or 31 32 range, or greater than 30 range. What which how many fluids or how many regions are how many planes of plane particle in this plane, how many particle have velocity more than 30 or less than 30 or greater than 25 is how many particles there with this velocity or this range of velocity. We need to find using this iso clip. So click on iso clip. Okay, we change the location to plane 1, and we need to create a visibility parameter using this option new. Click on new. This pressure is starting. I change this pressure to velocity. You can this use the similar method for velocity and similar method for pressure. You can do anything. You can change this equal, greater than, or less than, something like that. I'm using less than or equal to some value. This will, I'm using here 32, and just click a apply option. Okay, okay, you just contour off. Okay, we create a iso clip in the geometry with the visibility less than or equal to 32, and change the color option. Here it is mode is constant, you change to variable, and this change to velocity, and apply. Yeah, we got the geometry with 32 number of iso lines. We can create different iso width. It will helpful for um, it's not okay. 1 minute. It is not okay. It is not for. It is the number of renders is not available. Okay, colored this one. That is, this is showing the velocity with the less than 32. We can change this to 20, not 20. This can change to 38. Okay, you can change this to 10. Yeah, here it is, different one is there for 10, and the previous case different color. In this case this much only, how less than 10. Can change to this 15. You can see how many regions have less than 50, and you can change this to 28 and see how many regions, how much area is covered with the velocity less than 28. Like that we can change the pressure also. Here we can change the pressure to I think 600 is the range, so we can get the range from here. Okay, yeah, the pressure range is in between 600 and negative 1111. You can use this range. So I am going to change the iso clips for the variable. You can create another one variable pressure. So I changing the pressure below is greater than or okay, less than. I can use less than. Okay, 500. I change this to 500. Click on apply. Click on apply. You can change this to 200 or any values. Okay, this much only have 200, less than 200 pressure pascals. You can change this to 50 or not 50, 600. It will showing the region, how much area how much area covered with the pressure of less than 600 pascal. We can see on the plane. Okay, this way we can create different type of planes. Okay, okay, follow these methods and you just create this iso plane, streamlines, contours for pressure and velocity.